In this short video, we will have a brief discussion about the velocity in curvilinear motion. We consider a point P at x and y moving along a curve with the equations x equals f of t and y equals g of t, where t is time. By differentiating the position vector r equals xi plus yj with respect to t, we obtain the velocity vector where it is the v equals dr over dt simplified as dx over dt of I plus dy over dt of j. So we obtain v sub xi plus v sub yj as our velocity vector, while this is the position vector. And the magnitude of our v, or the speed, where the magnitude of v is equal to the square root of v times v simplified as square root of v sub x squared plus v sub y squared equals ds over dt, or the change of speed over time. So our direction now is equal to tan tau equals v sub y over v sub x. So we will use this formula to solve for the problem here in our example. So in our example, we need to find the magnitude and direction of velocity at time t, given that x is equal to 2 minus t, and y is equal to 2t cubed minus t at t equals 1. So we will have the given written. So x equals 2 minus t. So we need to get the derivative of the equation x. So the derivative of 2 minus t, so we know that it is equal to negative 1. So this will serve as our value for our v sub x. While we also need to get the derivative of our y with respect to time. So 2t cubed minus t is equal to 6t squared minus 1. So that will also serve as our v sub y. Since 6t squared minus 1 is a result of in indefinite form, so we need to use the value of t to get the definite value of our v sub y. So we'll substitute 6 times 1 squared minus 1. So we will have 1 squared is equal to 1 times 6 equals 1. Equals 6 minus 1 equals 5. So therefore, the value of our v sub y is equal to 5. So now, we already have the value of our v sub x equal to negative 1, and then our v sub y equal to 5. So now, we will solve for our velocity vector. So for our velocity vector, v is equal to v sub xi plus v sub yj according to the formula. So we will substitute the value of our v sub x, which is equal to negative 1, and then our v sub y equal to 5. So therefore, we obtain the negative I plus 5j as our velocity vector. And for the magnitude or the speed, so the magnitude of v is equal to the square root of v sub x squared plus v sub y squared. So again, we will substitute the value of our v sub x and v sub y, the negative 1 and 5 respectively. So we will get square root of 26. So this is the magnitude or the speed. And lastly is we will going to solve for the direction. So tan tau equals v sub y equals v sub x. So again, we will just substitute the values of our v sub y and v sub x, which is 5 and negative 1, so we get negative 5. So that means that now we already have the equation tangent of tau equals negative 5. So since the direction involves angle, so we need to isolate this tau out of the equation to get its value. So we need to have the inverse of tangent. So we'll add the inverse of tangent to both sides of the equation. Okay. So after that, we will get this. Tau is equal to tangent of negative 1. I mean, the inverse of tangent times negative 5. So we will have the value of negative 78 degree and 41 minute. So to get the direction, we will have 180 degree subtracted by 78 degree and 41 minute. So therefore, our direction is equal to 101 degree and 19 minute.